Dear students, Assalamu alaikum wa rahmatullahi wa barakatuh. I hope everybody is doing well and in good health. Today our topic of discussion is arithmetic mean and also we will discuss geometric mean, right? If you remember, in the last lecture we have covered total return and return relative and cumulative wealth index, right? In the total return you have learned how to compute the return from your investment. For example, if you want to make investment in any stock or bond, then how you can compute the total return. And also we have explained return relative. Whenever you add 1 with the total return is giving you return relative, and also where we can use return relative in the purpose we have made it clear. And in the last lecture we have also covered cumulative wealth index. And what was the purpose? If you remember, we have explained that if you want to make investment of $1 in any particular year, and then you want to check how much $1 will turn out after some years, then we were using cumulative wealth index. Okay, in today's lecture, as you know, total return, return relative, and cumulative wealth index are useful for a given single time period. What about summarizing returns over several time periods? So today, if you want to know that how much is the return or the rate of return over given period, if you want to check in the last 1 year how much is the average rate of return, then we are using arithmetic mean. Okay, these measures, if you remember, was just for a single time period. Now we try to know the average return or the return across the period. Okay, so in a very much simple word, what is arithmetic mean or simply mean? So according to Charles Pigeon, the best known statistic to most people is the arithmetic mean. Therefore, when someone refers to the mean return, they usually are referring to the arithmetic mean, unless otherwise specified. So the arithmetic mean customarily designated by the symbol x bar of a set of values is calculated as this. So dear students, arithmetic mean is just an average simply, and that is usually shown or designated by this symbol, right? Here we have x bar, this is the average, and then we have summation x, this is the observations or the values. We sum them, we add them all, and then we divide them over the number of observation. So simply this is arithmetic mean. Okay, today I'm trying just to show you the practical implications, the practical usage of arithmetic mean and also geometric mean, and how the arithmetic mean differ from geometric mean. Okay, dear students, let me show you in Excel. If just you try to compute the arithmetic mean from a given return in our example. Okay, just I try to compute the arithmetic mean for the return, as the return is given here, from 1990 into 1999. If you remember, in the last example we have worked on this, and this is the return relative values, and these are the return we have when you add 1. So this is called return relatives. So dear students, how you can compute the arithmetic mean from all these returns? So just simply, I'm just once again trying quickly to show you how these returns are computed, right, and how the return relative measured here. Okay, so the data I'm just copying from the same table starting from 1990 up to 1999. So we have a table here. Just you can come here. Okay, let me just copy the data from here. Okay, the data in this table simply is I'm taking the data from this table starting from 1990. Okay, so simply just snapping tool, take the snapping tool and start from 1989. This is the return, this is the dividend, and up to 1999. Very much simple, you students. Just copy this data into the Excel. Okay, now as you know, this is in the form of a picture, right? And I'm just typing all the data in this Excel sheet. Okay, so we have years and then we have index value. So this is the index value. I'm just copying, and this is the dividend we have. So starting from 1990, right? Look in this table, we have 1989, and then we have 1990, and drag it down to 1999. Okay, then we have index value. Okay, which start from 3.40. we have a dividend, and that is 11.05. Your students, you have to copy all the data here. Once the data is copied, then I'm not needing this anymore. Okay, just delete it. Okay, dear students, my topic here is what I'm just trying to measure is arithmetic mean. Okay, so the topic is arithmetic mean and geometric mean. Okay, I have to compute the arithmetic mean. First I need to find out the price change here. Okay, so if you purchase this stock in 1989, right, and then in 1990 the ending stock price is 330.22. so how much change in the price we have? So equal sign from 1990 subtract the value of 1989. So this will give you the price change. So dear students, the price change we may have either positive or negative. So if there is appreciation, then we have a negative value, positive value if there is depreciation. So as you can just observe, we have depreciation, so that is why the price change is negative. It means here in 1990 there is a loss. Okay, just drag it down to 1999. So this is the price change we have across 10 years. Okay, now how much is the total return? If you remember in the function or the formula I have explained, dividend plus price change, we have to edit, right? This is giving us the total return because this is annual dividend and this is the price change. So equal sign, just take the bracket, we have a price change and then we have dividend. And if you want to measure how much we have this in the form of return, as I've explained already, then you have to divide this over the initial investment, right? So it's mean the return we have is 0.031, as you can see here, and this is our return. If you want to check it, look, if you multiply this value with 100, then this will become how much? Minus 3.14. Just drag it down. So next value we have 30, and here is again 30 if you multiply with 100. Okay, this is the total return we have. So dear students, if you want to measure how much is the average return in this given period of 10 years, then we have a formula. And what is the formula? We have, as I have already explained here, summation x, right? And that is, look here, the formula for arithmetic mean is summation x bar is equal to summation x divided over n, right? So here you have to compute the arithmetic mean, which is x bar, okay, or simply arithmetic mean, which is x bar, right? How it is computed, summation n. It's mean you have to take you have to sum all of these values, right, and then divide by n. So in Excel we have a function automatically just put equal sign and then type average and take all these values in the range. Okay, this is giving you how much is the average return. So this is exactly we have x bar, right, the x bar, and that is equal to summation x. This is summation x, right, and divided by over n. Okay, so summation x, it means we have summed all these values, okay, then you divide by n, and n is the number of years. Here the number we have 10, from 1919 to 1999 we have 10 years, and that is we have 0.1876. Dear students, you can say the average return we have over here, that is 0.1876. okay, we cannot call it return if we do not multiply this with the percentage, right? So that is why I have just simply shown, you can say this is the value in the amount, you can say. And if you wanna call it return, then you must multiply all these values you have with 100, like this, okay. And if you just drag it down, then now we have return. So how much is the total return in the form of percentage? That is 18.7647. okay, dear students. But dear students, the use of arithmetic mean in finance is not appropriate. This is not used in finance, and what's the reason behind? I'm just explaining. So in finance we have to use geometric mean. So why in financial analysis or finance analyst is using geometric mean instead of arithmetic mean for computing the average return? This is, I'm just explaining. First, you need to know the difference between geometric mean, arithmetic mean, and geometric mean. Okay, let me explain. Okay, for understanding this concept, you must know what is arithmetic sequence and we have geometric sequence. For example, let me just explain it here. We have arithmetic mean and geometric mean. If you have $2, right, we have value of 2 here, and I'm just adding 3 with this 2, then this is equal to how much? 5. And again I'm just adding 3, this is equal to 8, right? So dear students, this is a sequence. In this sequence we have addition. It's mean in each value we have added 3. We have 2, we have added 3 with, that is equal to 5, and then we have added 3, that is equal to 8. And you can see this is arithmetic sequence. Okay, I'm just giving an example of arithmetic sequence. Now what is in geometric sequence? If you have 2, right? Okay, just let me just remove this dollar sign here. Okay, if you have 2, I'm multiplying this 2 with 3, and that is equal to how much? 6. And then multiply 6 to 3, that is equal to how much? 18. Okay, I just try to make it very much simple in a very much short and brief example. This is a series, and this is also a series. What's the difference here? Here we have terms, right? The first term with the first term we have added 3, we got 5, and then we have added 3, we have got 8. But in this sequence, with the first term we have multiplied 3, then we got 6, and then we multiplied 3, we got 18. So you can say here is the addition, right, and here is the multiplication. So this is called geometric sequence, and this is arithmetic sequence. So dear students, normally the arithmetic mean, this one, is used for a data if there is arithmetic sequence. Arithmetic mean is preferred for those kind of data which there is kind of arithmetic sequence, and geometric mean is preferred for a type of data when there is a kind of geometric sequence. For example, I'm just asking you a question. If you want to compute the average of this data, the average simply is, you have to take all the data, the average is 5, right? Okay, this is the average. So dear students, what function I have used? I have simply used summation x, x bar is equal to summation x over n, right? So how much is the average in this given data? The average is 5. So you can say you can also compute this average to the first value and then the second value divided by 2, and that is giving you the average value, which is in between. Like this you can do it. We have 2, the first value, and the last value, this, for example, is 8, and divided by 2. We look here, this is giving you 5, so in between this is 5. So this 5 is the central tendency for this data. You can say this is the average value for the given data. But here for the geometric sequence, if you try to know how much is the average, right? So if you're just using the same function like you have used in arithmetic sequence, here I'm just using arithmetic mean. So the first data, for example, is 2 plus 18 divided by 2. This is not giving you the in between value, while in the geometric sequence the average is 6, but the arithmetic mean is not giving you this value of 6, right? Okay, why? Because this $10 or 10 value cannot be the average for this data. Why? Because I'm just explaining it. This 5 can be the average. This is the central tendency. You can say this 2 is less from the 5 by 3, and this 8 is higher than the 5 by 3. So this 5 is the average, right? Okay, but the same is not true here in the geometric mean, because the geometric means the sequence is different. Here you have to find out the average 6, and the 6 can be only be calculated with the formula of geometric, right? Geometric mean. Okay, as I've explained, what is the arithmetic mean? The arithmetic mean is the summation of x bar is equal to summation x over n. How you can compute the geometric mean here? Okay, you have to take the product of all these values, right? Take the product of all these values, and then you have to take the square root. Okay, so simply if I just try to explain it this way, so if you try to find out geometric mean, right? So look, dear students, you have to take the product of all these values and just take the root. Okay, so we have the product, how much we have first 2, and then we have 6, and then we have 18, right? Look, we have taken the products of all these 3 values and then take the root. So how much we have? If there are 2 values, then you have to take 2 as a square root, but we have to take cube because we have 3 values, so here you have to take 3. Okay, dear students, if you have 5 values, then you have to take 5. If you have 10 values, you have to multiply them and you have to take 10. So this is a function of geometric mean. Now we are using this function here. Okay, so in Excel we have geometric mean. Just write geo mean and double click and just select this data. Okay, dear students, look, this is giving us exactly the value in between, but this value has not been given by arithmetic mean. So now what is the interpretation of both of these mean, arithmetic mean and geometric mean? Okay, let me explain it, dear students. Very much simple. Okay, if we say in geometric sequence, this is our mean value, which is 6. So the first value, this 2 is 3 times lower than 6. Okay, here you can say the 2 is lower from 5 by 3, but here this 2 is lower 3 times. It means this 6 is 3 times higher than 2. Okay, and this 18 is 3 times higher than 6. So you can say 18 is 3 times higher from 6 and 2 is 3 times lower from 6. So the distance is same. So that is why we say this 6 is the average value, the mean value. So the distance here and the distance here, because this is lower, the 2 is lower by 3 times and the 18 is higher by 3 times. So in between, this 6 is the average value. But in arithmetic sequence, we cannot say that this 2 is lower by 3 times. No, this 2 is just lower by 3 and this 8 is just higher by 3. So dear students, that is the logic. That is why for a data like this, you have to use geometric mean in order to know how much is the average value. But in data like this, when there is addition, not the multiplication, here we have a common ratio, means here we have a value which each value is multiplied, so the common ratio is here, right? But here we have only additions. That is why this is arithmetic mean and this is geometric mean, and the purpose is also clear here. Okay, dear students, as I've explained, arithmetic mean, that is simply the summation x over n. And what is geometric mean? As I have explained, that is to take the nth root of the product of the values, right? Okay, now dear students, here we have total return. Why we are not using arithmetic mean in finance? We have computed that the arithmetic mean is 18, but this cannot be appropriate. As you have seen, where the arithmetic mean we have computed was 10, which was not appropriate mean for this data. Similarly, this arithmetic mean cannot be an appropriate data for this series. You know why? The reason, because the nature of the data we have here is these are the return. In each return we have, right, in this series, that is compounding. It's mean the rate which you use, it's mean each value has been compounded. So that is why here we have compounding effect like we have here. So we have 2, we have multiplied the 2 by 3, right, and that is equal to 6, and here we have multiplied the 6 by 3 when we got 18. Similarly, these returns we have here, the multiplication rate is used, or in other words, all these return compounded, as here these value compounded. The same is here, these values compounded. Okay, so for example, we have this is the price change and this is the dividend. The total return we have 3.1358, right? Then this return increased, right, into how much in the next year, right? Then the same return increased into how much? If you remember, we have computed cumulative wealth index in the last video. I have explained that if you invest $1 in 1990, so how much $1 will turn out in 1999? So in the first year, when you make investment of $1, then it increased into a value in 1991, and the whole value is then increased by another rate for 1992, and the whole then increased for another rate in 1993. So that is why the $1 investment, that is compounding for 10 years, as this value has been compounded for 3 years and you got 6. So that is why, dear students, the data we have in finance is kind of not suited for arithmetic mean. That is why here we have the effect of the compounding, right? So the better use and the best use should be the geometric mean. So if you want to compute the geometric mean, okay, I'm gonna explain it in a bit more detail to make it much clearer. If you want to compute the geometric mean, then the formula I have explained, just write geo mean, okay, and take all the values. Okay, but here is a point, dear students, because we cannot put a negative value in geometric mean. For the geometric mean, we must convert all the values into positive values, and we have a negative value here. So what is the solution for this? We can use return relative, right? And return relative, we are just adding 1 with all these values, and then first we have multiplied all the values with 100. Remove this, just have a value without 100%, and now you have to add one with all these values. Okay, now just drag it down. Now we have all the values, we have positive. So dear students, how you can compute the geometric mean, right? As I've explained once again quickly, in geometric mean, if you want to just compute the geometric mean, right, and this is equal to, you have to take the nth root of the product of return relative. So all we have, these are return relative, right? So you have to take the product of all these values in our example. So we have 0.9, we have 0.969, right? And then you have to multiply this with 1.3, right, 0, 0, and you have to continue this up to 1.209, 1.2209, right? I'm sorry for this. Okay, now you have to take the nth root. Okay, we have 10 values, and then you have to take 10. Very much simple, dear students. You have to take the nth root of the product of return relative. first you have to compute return relative as we have done here, and then you have to multiply all these values, and then you have to take the nth root. How much is n here? That is 10, so that is why we are taking 10. But dear students, when we compute the geometric mean from the final answer, you have to subtract 1. You know why? Because for the purpose to convert the negative values into the positive, we have added 1 here, right? So if you want to just get back the normal value, the average value, then that is why from this geometric mean I'm subtracting 1 to know how much is the average return. Okay, now dear students, I'm just using the same function here in Excel. So geometric mean, and take all the return relative values here as we have done, but you have to minus 1 from. Look, you have to take geometric mean and then you have to minus 1 from. So the answer is coming 18, 0.18, or you can say 18%. Okay, what does 0.18 mean? Dear students, this means the average rate of return we have here, right? That is 0.18. Which means as you can see in the first year our data increased. How much is the rate of return? 0.03, or you can say 3.14, negative 3.14. The rate of return we have negative, and here we have the rate of return is 30. It means in the second year your investment will increase by 30%. In the third year your investment will increase by 7.4%, 43%, in the fourth, in this way. So these are the rate of return given in each year, right? So you can see how much is the average rate of return. This is 0.18. How much is the average rate of return? It means if you make investment in any year, so passing 1 year, after 1 year, by average your return will increase 0.18. Okay, the difference here is the arithmetic mean we have 18.76, but here we have 18. Geometric mean is very much accurate, as I've explained, because here we have the compounding effect. What is the compounding effect? It means each year your investment increases, right? Whatever you have made investment, after 1 year how much you have earned, the same is increasing and increasing. So that is why we have compounding effect. And when there is compounding effect like what I've explained here, then you have to use geometric mean, not an arithmetic mean. And keep in mind, geometric mean, that is always less than arithmetic mean, slightly different. So if the outlier we have in the data is very much higher, then the difference is also coming higher, but the outlier is not very much higher, so that is why there is a very much slight difference. But keep in mind, always the geometric mean is lower, because in arithmetic mean we are not having the compounding effect, right? Here we just try to know the central tendency, but here we just try to know the average return, right? Means what is the rate which is in between, right, and the rate of increase which is used, that is multiplication. So that is why we are just using geometric mean, dear students. And once again, in arithmetic mean the result is always higher if you try to compute arithmetic mean, but in geometric mean that is slightly different, because in geometric mean if you try to compute the average return is coming 10, if you remember, because they try to compute the central tendency, but that is not meant by geometric mean, something else is meant here. Okay, the conclusion, dear students, in finance and in analysis or whatever, just data, if that is having kind of multiplication or compounding effect, then the better way to calculate is geometric mean, not arithmetic mean. Okay, dear students, now you have learned what is geometric mean. Let me explain further. By this 0.18 we mean the average return. It's mean here, as you can say, if you make an investment in 1990, so your return after 1 year is 30%, right? Okay, but in 1992 your return is 7.43%. But what is the average of all these return? You can say that is 0.18. Or in other words, if you remember, in the last lecture I have explained cumulative wealth index, right? In the cumulative wealth index you have learned that if you make an investment in this year, so after 10 years how much your investment will increase, how much your total wealth will increase. So we have a formula. Let's just quickly give you how it is computed. Okay, we have cumulative wealth index for 1992 1999. Okay, if you just want to know that if you want to make investment here in this year, so how much that will increase in 1999. So what is the formula? If you remember, for that you have to just take the product of all the return relative. So take the product of all the return relatives starting from 1990 up to 1999. Okay, and that is equal to how much? That is equal to $5.23. What does this mean? We have already explained. If you make an investment of $1 in 1999, right, then in 1990, then in 1999, after 10 years, your $1 will increase into $5.23. In other words, your total wealth will increase into $5.23. Now a question, you can say your wealth by average each year increase how much? 18%. Okay, let's make it 18%, right? Okay, once again, if you want to make investment of $1 here, right, $1 investment if you want to make here, and this $1 will increase into $5.23 after 10 years, right? Okay, each year this $1 increased by average how much? 18%. Okay, let me prove it. For example, if you want to make investment of $1, so how much is the future value after 10 years? So the future value of after 10 years, so you can compute it like this. Okay, we have the present value which is $1 if you want to make investment of $1, right? And then we have 1 plus in the future value formula. How much is the interest rate? The interest rate is 18%, this one, right? And just raise into power 10. What does this mean? Yes, we try to know if we make investment of $1 and the average return is 18%, which is here, right, for 10 years, that will become how much? Look, press enter. Okay, just remove the dollar sign, press enter. Look, this is equal to 5.23 exactly, right? So I've just used a future value. If you want to make investment, okay, the cumulative wealth index is just computing how much is the final value, and if you just want to prove it, so we take $1 and we invest it for 10 years for the rate of 18%, that is equal to 10%. So that is why, dear students, the average rate is 18%. Or in other words, we say if you make investment of $1 here in 1989, so after 1 year this $1 will increase how much? 18%. Just click on this value and increases 18%. And if you remember, I have explained if you want to increase this one by 18%, so you have to multiply this with 1.18. 18%. And the same value in 1991, again by average increase 18%, so equal to this value, multiply this with 1.18, right? And then if this value again is increased 18%, is equal to how much? 1.64. And if this increase 18%, 1.93. And finally the final value we have is 5.23. okay, look, if you make investment of $1 in 1999, it will increase into 2.3. so in all these values, what is the average rate? That is 18%. look, we have in each value we have 18%. And this average rate of return in each year we have computed by the help of geometric mean. And you cannot accurately compute this 18% using arithmetic mean, because this arithmetic mean is not an appropriate method. If you are just using 18.7%, you are using this calculation, so this will never give you this value, which is final in the accurate value. So dear students, I hope you have learned what is the difference between arithmetic mean and geometric mean, and where we can use both of them. So very much simply, in conclusion, arithmetic mean for general calculation, right? When there is no outliers, or when the data set is given normally 10, 15, 20 years, and also there is no compounding effect, there is no common ratio, then you can use arithmetic mean. But geometric mean, if the data is kind of compounding, right, and there is as I've explained, a common ratio. What is a common ratio? If you divide 18 by 6 and then divide 6 by 2, the ratio is same, right? That is called the common ratio. The common ratio here is we have in geometric mean. So that is why, dear students, as you can see in our data also, why we have used geometric mean, because all these data the data is compounding. We have 1 and it compounded into 1.18. The total value then increased by 18%, and this total value again increased by 18%. So that is why in our data we have compounding effect. When there is compounding effect, then the appropriate method is geometric mean, not the arithmetic mean. So dear students, I hope you have learned. So if you have any question, you can share with me in the WhatsApp group. So have a nice time and wish you good luck. Assalamu alaikum warahmatullahi wabarakatuh.